You're shopping for a bike, and the friendly salesperson offers you to test the prototype for a new model using new technology straight out of space. It turns out you're already using some interstellar inventions on a daily basis. Regular inflatable rubber tires can't do so well on the perilous, rocky, and sandy terrains of the Moon or Mars. Curiosity Mars rover got some damage to its treads just 16 months into its mission. That's why airless tires relying on a mix of nickel and titanium were invented for NASA rovers. The material is flexible thanks to its tight molecular structure and can return to its original shape every time it deforms. The same airless technology should work great with bike tires down on Earth. The tires are tube-shaped and squash down whenever you roll over a bump. They will develop perfect shape memory over time. They're supposed to work best on gravel, trail, and mountain bikes. When it wears off eventually, the company plans to retread the tires to get the bike back on the trail and to make it last for years. The previous airless tire models were made of patented foam, supposed to last for up to 5,000 miles. They didn't take off because they made the bike too heavy. The new model is supposed to solve that problem and give the world innovative, lightweight, and durable tires. The same tech can be used in an all-terrain car and truck tires, high-performance sports, commercial aircraft, and even search and rescue missions. You gotta thank NASA for that comfy memory foam mattress you're using every night. Back in 1966, the original idea behind memory foam was to customize seats for astronauts to somehow ease the effects of G-force on takeoff and landing. It would be too impractical to create a custom seat for every flight, so memory foam became a perfect solution. It easily adjusted to an astronaut's body shape and went back into a rest state when not in use. Memory foam became available to the general public in the early 1980s and is now used in products from mattresses and pillows to amusement park rides, horseback saddles, and football helmet liners. Lenses used to be made of ground and polished glass. In 1972, a new regulation made their manufacturers turn to plastic to make them shatter-resistant. The new lenses were too prone to scratching, so NASA's invention of a diamond-hard coating for astronaut helmets and other plastic aerospace equipment came in handy. The new tech was further developed and used for the production of scratch-resistant plastics. It's now used in most sunglasses, prescription lenses, and safety lenses in the US and around the world. The next time you clean your car's interior with a dustbuster, remember, you gotta thank NASA and their Apollo space mission for it. They wanted to come up with some portable self-contained drill to extract samples from below the moon's surface. They developed a computer program to produce optimal motor power and minimize power consumption. This program was later adapted and used to create a whole series of useful battery-powered home devices. The most famous of them was the cordless miniature vacuum cleaner under the original name of Dustbuster. In case you didn't trust the name, space blankets are indeed a product of NASA research. They're lightweight, usually gold or silver in color, and capable of reflecting up to 97% of radiated heat. That's just what you need to reduce heat loss from the body and stay warm and comfy in space. The material was originally designed for the exterior surfaces of spacecraft. Now you can see marathon runners at the end of the race wrapping themselves in those blankets to regulate body temperature. It normally drops right after you stop running. Another NASA invention is insulation called radiant barrier, made from aluminized polyester. It was designed to survive in wildly cold space temperatures and is now used in most home insulation. Freeze-drying tech for food was not created but greatly improved by NASA to pack more snacks on long Apollo missions. The idea is to cook food, then freeze it under low pressure, and then slowly heat it in a vacuum chamber to remove ice crystals. To bring it back to normal, you just have to add water. Thanks to this tech, food maintains 98% of its nutritional value with only 20% of its original weight. It's a great help for backpackers, disaster relief programs, and anyone who needs to pack light and still get proper nutrition. The infrared thermometer that lets us check temperature from a distance was developed with the support of NASA as well. It measures thermal radiation emitted by your eardrum a lot like they measure the temperature of stars and planets. Each device has a lens that focuses light from the object onto a special detector that converts radiation into an electrical signal and then into temperature you can see on a display. It's used for many purposes, from monitoring hotspot temperatures in mechanical and electrical systems to checking the temperature of visitors in public spaces. In the early 1960s, headsets for airline pilots used to be really bulky. They often used handheld mics to communicate. NASA needed a more reliable and lightweight technology for their missions to ensure communication, especially in case of emergencies. They got in touch with the pilots. Just 11 days later, the team came up with a microphone headset unit that could be used by astronauts to communicate with one another and with Earth. The headset was later improved and used for Mercury and Apollo missions. The world was able to hear Neil Armstrong's most famous phrase as he landed on the moon, thanks to that wireless headset. You gotta thank NASA for the improved version you use today. The idea behind LED technology dates back to the late 1980s. Back then, NASA was looking for a way to grow plants in space. They tested the tech using wheat and just red LEDs. It wasn't a success at first, but they solved the problem using blue fluorescent lights. The technology was developed and used in many medical devices and everyday items like electricity-saving LED bulbs. These days, they're way more efficient than their ancestors. Every time you take a selfie with your friends, you're using the tech that originated from the one for interplanetary missions cameras. NASA scientist Dr. Eric Fossum developed special active pixel sensors to make those cameras as small as possible and maintain the high image quality. This tech has become the leading one in the digital imaging industry. It made it possible to add miniature cameras to smartphones and other gadgets. Astronauts spend long periods of time in weightlessness and need a way to exercise regularly to stay in good physical shape. NASA took care of it and designed the anti-gravity treadmill, stimulating added weight and mimicking gravity. On Earth, the same method helps to lighten the load on your legs as you're working out. This tech is used by professional athletes and people trying to get back on their feet. You gotta thank NASA for your favorite pair of athletic shoes. They came up with a rubber molding process to absorb shock in space helmets and suits. The same idea was applied to athletic footwear and opened up new possibilities for professional sportsmen. And they're just way comfier for everyday use. The computer mouse was invented as part of a huge project aimed at augmenting human intellect. The inventors came to NASA in 1966 to test the mouse. It turned out the mouse was better and faster at manipulating objects on the screen than other gadgets like the light pen. The first mouse came with a cord in the front, but they moved it to the back to get it out of the way. The first patent for something that looked and worked like a joystick was filed in 1923. But it was NASA who made it something widely used. Astronauts in bulky suits needed a steering mechanism that would work with one gloved hand. The joystick was the best choice that spread to training simulators for astronauts and home computers. Invisible braces are a product of Ceradyne and NASA's Advanced Ceramics Research Program. You probably use them to straighten your teeth, but the original idea behind them was to find some material to use in structures protecting radar equipment. It had to be as transparent as possible for radar waves to pass through easily. It was doing well at its job, and in 1986, they got the idea to use this transparent and strong material in the dental industry.